Welcome everyone, hope you're all doing well. We're now commencing our video series on section 8.2 equations of planes, where we'll be reviewing all the homework given. So let's start off with question 5. I think I'm going to do A and C for this problem. So write the parametric equations of each plane given its vector equation. Maybe I should do it over here actually. Okay, so I need an x, y, and a z. And now I can just read it off from the given vector equations. So it's going to be 1 plus, or I guess I should do minus 3s plus 9t. I'm just reading it off, the components. 9t. Okay, for y it's going to be 3 plus 4s plus 2t. And then we have minus 2 minus 5s minus t. So just kind of reading off the components, figuring out what x, y, and z are. Sorry, excuse my voice. All right, moving on to C. Same ordeal. X, Y, Z. So we have 0 plus 0s plus t. So 0, 0, and then it's just going to be 1 times t, so it's just t. Okay, what about the next one? We have 0 again, plus 3s, and then plus 0t, so nothing for t. That's the y. So this, this, this. And then we have 5 plus 0s plus 5t. All right, good. Moving on to question 6. I'll do this one over here. This time we're asked to write the vector equation of a plane given its parametric equation, so the reverse process. Let's do A and C again. Okay, so we can write it as the ordered ordered trio, I guess you could say. X, Y, Z. And I'm just going to look component-wise, so I see 9, 4, negative 1, 9, 4, negative 1. For the S's, I see, so I'm going to put an S here, 3 minus 7 minus 5. Brilliant. Plus, now I need the t parameter outside. And I got a minus 2, then a 1, and then a minus 4. Minus 2, 1, minus 4. Alrighty, perfect. Let's do C. Let's write the ordered triple X, Y, Z. Because remember, planes, the only plane that can exist in 2 dimensions is the whole Cartesian plane. So we're always going to be talking about planes in 3 dimensions. Okay, for C, so we have Another way you can think about it is you just got to see what's beside the t, what's beside the s. And if there's no t or s beside that number, then it's going to fit into the position vector spot. So we have a -6. The y contributes just number without a variable, so it's going to be 0. And then we have 5 plus s. So the x contributes nothing because there's no number beside the s in the x spot, in the x parametric equation. Sorry. So we have s 0, then we have an 8, and then nothing for the z parametric equation, 0 again, plus t. So the x has no number beside the t, so we have 0, and then 0 for the y, and then -13. Okay. Perfect. Now let's move on to question 7. Determine if each point is on the plane. So I'll do A and C here as well. So first, actually, before I proceed, I'm going to take my vector equation, x, y, z, 6, -7, 10, plus s, 1, 3, -1, plus t, 2, -2, 1. And I'm going to write the corresponding parametric equations, so x, y, z. So I'm doing all this pre-work before I actually even begin problems A and C. Just to set myself up well. So parametric equations come simply. 6 plus s plus 2t. Beautiful. -7 plus 3s plus minus 2t. And the final guy, 10 minus s plus t. Okay, perfect. Nice. Now I can write down problems A and C. So the first problem is asking if the point 10, -19, 15 lies on the plane. All right, so let's sub the corresponding components of our point into our parametric equation. So we have 10, -19, 15, 6 plus s plus 2t, -7 plus 3s minus 2t, and 10 minus s plus t. Just want to make sure this parametric equation is right. Yep. Minus 7 plus 3s. Perfect. Okay. Okay, so let's look at this. We have 3 equations. So I want to turn your attention to this now. We have 3 equations. But only 2 unknowns, s and t, right? So there's not really a word for this that I know of in the math jargon, but I like to refer to this system as being oversaturated, meaning there's more equations than there is unknowns. So when you're used to doing elimination or substitution to solve a system of equations, there's an equal number of equations and an equal number of unknowns. So this system has 1 more equation. Pretty much what we can do is, how you're used to it from elimination and substitution, let's just pick 2 equations. So then we can solve for the two unknowns in those two equations and then see if those s and t values work in one of the other equations. Okay, so usually your choice of equations, you're going to be more clever. I'm just going to choose at random so you understand the process, I guess, better. I personally like this one, so I will label these equations 1, 2, 3. Okay, so I'm going to choose to work with 1 and 3 actually. All right, and the reason I like 1 and 3 personally because there's the s and there's the minus s, so I can add the two equations and boom, s disappears, right? So I'm gonna do 1 plus 3. Okay, so what will that be? It's gonna be 10 plus 15, 25 equals 25 equals 6 plus 10, that's 16. S plus negative s, it's going to be 0. And then 2t plus t, it's 3t. Lovely. And now I can just solve for t. So t is going to be 25 minus 16, 9 divided by 3, get t equals 3. Okay, so now I have to substitute it into one of either 1 or 3. I've reduced my problem to only working with equations 1 and 3. So pick two equations and proceed with the elimination process. Only with chosen equations. Okay. So now I'm going to sub this. I'll sub this into 1. Sub this into 1. So what do we get? We get 10 equals 6 plus s plus 2 times 3. And then s will be equal to, do this all in one step. 6 plus 6 is 12. 12 is negative 2. So yeah, I've proceeded only with doing elimination. I'm doing the whole elimination process only with equations 1 and 3. Perfect. Now check t and s values in the non-selected equation. So in that case, that would be, this is 2. So I'm plug in t equals 3 and s equals negative 2. Into 2. Okay, perfect. So what do we get? We get negative 19 equals negative 7 plus 3 times negative 2 minus 2 times 3. Okay, so let's check if left-hand side equals right-hand side. Get a negative 19 here. Negative 7 plus 3 times -2 minus 2 times 3, -19. So left-hand side does equal right side. This is a mathematically true statement. -19 is obviously equal to -19. So the point does lie on the plane. So therefore, P is on the plane. Perfect. Okay. I'm going to move on. I'm going to do C over here. Quite bad with space. Yeah, I'll do C over here. Okay, so I'm not going to include all the details that I did in the last question, but I'm going to do the same process. So I'm checking if the point P 8.5, -3.5, 9 is on the plane. All right. So let's see. How can we attack this problem? Which equations should we use? I guess I should first write down all the equations. We'll call them 1, 2, 3. 8.5, -3.5, 9. Okay, so that's writing down all the parametric equations with the point P's components subbed in on the left-hand side. All right. What can we do next? Sorry. I wanted to make sure we were recording. How about this time, I take equation 1, so just to show you a different way how to do it, I'm going to take equation 1 and multiply it by -3. So I'm going to take 1 times -3. This is a different way of eliminating s, and add it to 2. Okay, so then 1 times -3, so that's going to be 8.5 times -3, that's -25.5. 6 times -3, that's -18. Minus 3s, minus 6t. Okay. And I still have this guy. This is the same. So I get left with minus 25.5 plus -3.5 minus 29. So now I'm working with equations 1 and 2. I've chosen 1 and 2 to work with. And then minus 18 plus -7 minus 25. The s's cancel. Minus 6 plus -2, that's minus 8 t. So t is equal to minus 29 plus 25 minus 4 divided by minus 8, 0.5, or 1/2. Okay. I'll sub this into sub into 1. I guess I could do sub into 2 actually. So my choice of equations is a bit more complicated here, but I'll still get the same result. Minus 3.5 equals, cramming everything in, minus 7 plus 3s minus 2 times 0.5. So that s is equal to minus 3.5 plus 7, 3.5 minus plus 1, 4.5. Divided by 3, 1.5. See if I did my math right. Minus 2 times 0.5. Yep. And now I can plug in t equals 0.5 and s equals 1.5 into, so the equation I didn't use in this process was 3. So when I do that, I get 9 equals 10 minus s plus t. So then that equals, sorry, gotta plug it in. Minus s 0.5 plus 0.5. So 9 equals 10 minus 1.5 plus 0.5. 9 equals 9. That's a mathematically true statement. So therefore P is on the plane. Perfect. I still have some room left over. I think I will move, this was meant for the next part of the video, but I'm just going to move it down here and then solve the other problem. So determine the x, y, and z intercepts of each plane. So I'm going to do problem A in this case. This is 9A. I'm going to determine the x, y, and z intercepts. Okay, so x, y, z. Actually, before I even begin, I'm going to find the parametric equations again. X, y, z, 6, negative 9, negative 8. Oh, I was looking at the wrong one. 186. (186) 1, negative 12, negative 12. Plus 2, 4, negative 3. Okay. So the parametric equations are x, y, z. 1 plus s plus 2t. 8 minus 12s. 8 minus 12s plus 4t. And 6 plus negative 12s plus or minus 3t. Perfect. And it's asking us to find the x, y, and z intercepts. So I'm only going to do problem A because this problem is quite long. So to find the x-intercept, y-intercept, and z-intercept respectively, I set the other coordinates equal to 0. So y equals z equals 0. In this case, x equals z equals 0. And again, for this case, we have x equals y equals 0. Okay, so x equals 1 plus s plus 2t, 0 equals 8 minus 12s plus 4t, and 0 equals 6 minus 12s minus 3t. Perfect. So let's do the x-intercept first. Again, we're in a similar situation here where what we should do is the system is oversaturated if you ignore x. We have 3 equations, 2 unknowns. So let's solve for s and t in the latter 2 equations this time. So it's automatically selected for us what we should solve, and then plug those s and t values back into the x equation. Similarly for y and the z-intercepts, that's the same process. Okay, so I'll call this 1, and I'll call this 2. Okay. So what we can do is we can recognize that it's quite easy to eliminate s here if we just minus the 2 equations. So we'll do 1 minus 2, or 1 plus negative 1 times 2. Yeah, 1 plus negative 1 times 2, yeah. Similar thing, if you want to think about it like that. 1 minus 2. That's going to result in, we're going to have 0 equals 8 minus 6, which is 2. Then it's going to be 0. Then it's going to be 4 minus negative 3. It's not just 4 minus 3, it's 4 minus negative 3. Remember that. So 7t. So 2 plus 7t. So we get t equals minus 2 divided by 7. We get minus 2 over 7. Keep your answers in exact form here. Okay? And then we'll plug this into either 1 or 2. Let's plug into, I'm choosing at random, plug into 1. Okay. So we get 0 equals 8 minus 12s plus 4 times negative 2 over 7. So what's s equal to then? 0 equals 8 minus 12, what do we have? 8 minus 12s, 4 times 2, negative 2 over 7, that's going to be 4 times negative 2, that's negative 8. It's going to be minus 8 over 7. Just doing multiplication with some fractions. And we have 8 minus 8 over 7. Now I'm using my calculator here. So that's going to be 48 over 7 on the right-hand side, moving it over. Okay. Dividing this by 12, and we get 4 over 7. For this one, I use my calculator. Now, I'm going to plug both t and s, plug evaluated t, s, into remaining equation, which is 1 in the x equation. So we have x equals 1 plus 4 over 7 plus 2 times negative 2 over 7. What does x equal? 1 plus 4 over 7 plus 2 times negative 2 over 7. You get 1. All right. Let's find the y-intercept now. So this, you can tell these questions are quite long. So we have x. This video's length is already exceeding quite a long time. Sorry about that. 0, y equals 0. I'll call this 1, call this 2. We have 1 plus s plus 2t, 8 minus 12s plus 4t, 6 minus 12s minus 3t. Okay. So here, we have to work with equations 1 and 2, the ones I labeled. What can we eliminate here? I think s is a good choice to eliminate again. So this time, I'm going to do 1 times 12, but then I'm just going to add it to 2. So I'm eliminating s here. So how is that going to look like? This is going to be a bit more complicated, so I'll do this in 2 steps. It's going to be 0 equals 12 plus 12s plus 24t. That's equation 1. I'm adding it with 2, which is 0 equals 6 minus 12s minus 3t. So when you add these all together, we get 0 equals 12 plus 6, that's 18. The s's will cancel, and we're left with 24 plus negative 3, which is 21t. So then t equals, don't be scared of fractions, we have minus 18 over 21. Okay, let's plug this bad boy into 2, or I can also do 1, but I'll just do 2 to keep things different. It doesn't really matter. So then I get, what do I get here? If I plug into 2, I get 0 equals 6 minus 12s minus 3 times minus 18 over 21. Okay, nobody expects you to do this kind of mental math. So we got 6 minus 12s minus 3 times 18, 1, plus 18 over 7. That's in reduced form. Yep. Okay, and then s is going to be equal to 6 plus 18 over 7. 60 over 7 times. S is equal to 5 over 7. Okay, Then same deal, plug evaluated t and s into remaining equations. So I'm just going to indicate that by this, because I don't want to have to keep breaking that down. I guess I could do something better. Oh, this is going to be annoying. Keep it at that. Okay, so then y equals, what's the y parametric equation? 8 minus 12 times 5 over 7 plus 4 times negative 18 over 21. And then y equals 8 minus 12 times 5 over 7 plus 4 times negative 18 over 21. We get negative 4. Comes out quite nice even after those fractions. Surprising. Okay. And then the z-intercept. Same ordeal. Let's get this done. This video's length has already gone quite too long, I feel like. 0, 0, z equals, I'll set this to be my 1, my 2, 1 plus s plus 2t, 8 minus 12s plus 4t, and then 6 minus 12s minus 3t. So what can I eliminate from 1 and 2? Let's eliminate t actually in this case. So let's do 1 times negative 2 plus 2. So that'll eliminate t. You'll see why here. So I got 1 times negative 2. That's going to be 0 equals negative 2. Negative 2 minus 2s minus 4t. And then I'm keeping the second equation the same. 0 equals 8 minus 12s plus 4t. Bye-bye t. So we have 0 equals, remember I'm adding, I guess I should indicate that. Minus 2 plus 8, 6, minus 2 plus negative 12, minus 14s. T is gone. We get s is equal to minus 6 divided by negative 14, so it's 6 over 14. Okay. So now, again, by random choice, I'll plug into 1 this time again. So I get 0 equals 1 plus 6 over 14 plus 2 times t. So then get 0 equals 1 plus 6 over 14, which is 10 over 7. Plus 2t. So minus 10 over 7 divided by 2. T is equal to 5 over 7. Oh, sorry. Minus 5 over 7. Perfect. Plug it into the z equation. So z equals 6 minus 12. S was 6 over 14. Minus 3 times a negative 5 over 7. Z is equal to, plug this into your calculator, 6 minus 12 times 6 over 14 minus 3 times negative Wow, 3. Perfect. Okay, so that's all of our intercepts. So therefore, x-intercept, y-intercept, z-intercept, 1, 0, 0. Y-intercept, we got 0, negative 4, 0. And for the lastly, 0, 0, 3. Okay, that concludes this video. I'll see you guys again to take up question 10, and that'll wrap up section 8.2 on equations of planes. Thanks, guys.